We have already learned about quite a few dispersion measures. These included the most popular variance and standard deviation and the robust MAD. So it might seem unnecessary to learn about yet another measure of dispersion, the interquartile range. Just as MAD is a robustified version of standard deviation or variance, interquartile range is a robustification of range. Not that it is used much, but still we should know it because it is closely connected with an important graphical representation, the box plot or the box and whiskers plot. Let us understand interquartile range pictorially in relationship with the range. Imagine the data points along a number line as usual. When we define range, we looked at the two extremes and took the distance between them. We noticed that the two extremes are very likely affected by outliers, and so range was not robust at all. So let's shave away part of the two extremes from both sides. Now this is just like trimmed mean, but here we shall trim off 25% of data from either end, so that leaves 50% of data in the middle. Now we take the range of that. That is the interquartile range. In this video, we shall compare the robustness of IQR with that of the standard deviation or variance. Now for this I have a little data set here. We have got how many? Let's see. From row 2 it goes on all the way up to row 101, which means I have got 100 values of the variable, 100 cases, and they all look more or less similar. So just do a quick rundown. They are all more or less similar. They are nothing very strange or unexpected ups and downs. Okay, so now we want to compute first the standard deviation. So let's just do that. Standard deviation, and I will write it here. So I write ST dev, and I know it starts from A2 and goes on all the way up to A101. So that is the standard deviation. Okay, now let's try to compute the interquartile range. So I would first compute Q1, and that is equal to, I would have quartile A2 to A101. That is, oops, what happened? Sorry, I should have specified it is the first quartile 1, and then I want to do the same thing with the third quartile. So it is, I'll first copy it and then there will be a mistake. Now this value is wrong because you just see it has moved it to A3 to A102, because since I moved it, the range also moved. So what I shall do is I will just correct it here, A2 to 1, and this will be 3, quartile 3. So let's just form the IQR, that is this number minus this number, which is this. So I have got the standard deviation, this measures the dispersion, and IQR also measures the dispersion. Remember, there is no reason why IQR should be same as standard deviation or anything like that. It won't be in general. They are measuring two different quantities. Both of them have the same spirit, namely the spirit of dispersion, but these two numbers are not supposed to be close or anything. Okay, now suppose I take this data set. Now, when I was typing this dataset, suppose someone entered this dataset, this was 101.94. Well, when the guy was typing, he just forgot to put the dot. So he typed 101.94. So let's quickly remember these values. Maybe I will just have a little, I will just copy this thing. So I will take these things, Control C, and then I want to keep their old values. I will just right click. Now these are all formulae. I do not want the formulae, so I will say paste special and unformatted text, and then I will hit OK. So I get a copy of these with the advantage that these numbers are live. Whenever I change this value, these values will change, but they will remain static. So I will possibly write old values and these are current values. Okay, now let's try this. I come to this, say this line, and I delete my this. So now the number is 101, a huge number. Hit enter. And you will notice that this has not changed at all. Basically. So essentially this is the same thing, old thing. But these have changed a lot. This has changed a lot. This 1000, it has become 1009, and this has become, this is the old value. So you see what I mean by saying standard deviation is not at all robust. Even this minor mistake, this is a very minor mistake, you just forgotten one dot and you see it wreaked havoc. So standard deviation is not robust while IQR is robust.